Okay, well, welcome to Chapter 4. Chapter 4 has to do with triangles and all sorts of theorems and postulates regarding triangles and congruent triangles. The first theorem is the triangle sum theorem. This is something I'm sure you worked with in middle school, but we're going to talk through why it is true. So, as you were taught, triangle sum theorem says that the sum of the measures of the angles the triangle is 180 degrees. So in this picture, you obviously have angle A, angle B, angle C. The measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180 degrees. Okay, your book actually has a nice little diagram that helps you sort of visualize what that means. So as you can see in the picture below, if the three angles of a triangle are cut out, or you tear off the triangle angles from and take them apart, if you can put them together, you can actually form a line. So it's almost like a linear triple. There's no such thing as that, but when you put those angles together, they do form a line or 180 degrees. Okay, next, there is a couple of auxiliary lines that you can use to help you with proofs in geometry. Both of these actually were talked about during some of your true-false questions earlier in the semester. And then these two theorems, one of them says, through any point not on a line, there's exactly one parallel line. So basically all that says is that if you have a point and it's not on a line, and those two things are given to you, there's going to be exactly one parallel you can draw that'll go through that point. And then that would make these parallel. So if you are given a point and a line, there's exactly one parallel line that'll go through that point. The second one says through any point not on a line, there's exactly one perpendicular as well. So again, if you are given a point and then you are given a line, okay, there is going to be exactly one perpendicular through that point perpendicular to the given line. So both of these theorems can be helpful in different types of proofs. So first one, we are actually going to prove or just talk through the proof of the triangle sum theorem. So we're going to prove that angle A, the measure of angle A, plus the measure of angle B, plus the measure of angle C equals 180. Well, here's the thing. We need to use either a previously proven theorem or a postulate or a property to start our proof. And really, if we want to get to 180, there's really one obvious choice to help us with that. And that is going to be supplementary angles will add up to 180, or that a linear pair also adds up to 180. Well, you can see in this diagram as it is, neither of those things are going to come from just a triangle. So that is when we start thinking about using one of our auxiliary lines. So what we're going to do is we are going to use the one that says a point, so point B, not on the line AC, there is exactly one parallel. So I'm going to draw myself a parallel through point B, and I'm going to mark it parallel to AC. Well, as we know from our parallel line theorems and postulates, well, we have alternate interior angles are congruent if we are given parallel lines. So once we have these parallel lines, then we can start labeling angles that are congruent to each other. So for example, this angle A here, using alternate interior angles, as you can see right here, would be congruent to this angle. Okay, same with angle C. I'm going to mark that differently. That would be congruent to this guy up here. And then as we briefly talked about, this is kind of like a linear triple, but you would officially in an official proof, you would take these two angles, do angle addition, and then take this obtuse angle with this last angle, and then use the linear pair. But as you can tell, and let me just put some maybe better angles in here. Let's put some numbers in there. That's 1 and that's 1. And then this 2 and this is 2 and then this is 3. But just as a visual, these 3 angles here together are gonna have to be add up to 180 degrees. So basically you can take this picture and add those 3 angles is equal to 180, and those are also the same 3 angles that are in the triangle. So that is the basic logic on how you prove the triangle sum theorem. If we were going to do that officially, it would be a lot more complicated, but that is the basic logic. Okay, just some basic examples here. So why don't you pause and try these on your own? You're just using the triangle sum theorem. Okay, so welcome back. This first one, you have x plus 82 plus 43 is equal to 180. That's easy enough. You can combine these. That's going to be 125 is equal to 180. Subtract the 125 and you get 55. So the measure of angle B would be 55 degrees. Easy enough. Okay, next one is slightly harder, but still the same basic idea. You're going to take these 3 angles, the expressions, add them together, and set that equal to 180. So combine like terms here, we have 5, 9x, and then we have 30 and then minus 30. So those are going to cancel, and you get x. 9x equals 180. Divide by 9, and you get x equals 20. Now, it is always a good idea to plug that into the picture to make sure that things make sense. So in here, we got 60 plus 10 is 70 degrees. Here we have 80 minus 30, which is 50 degrees. And then 40 plus the 20 is 60 degrees. And then here we get 130 plus the 50 is 180, and that checks out. Okay, so that's the basics for triangle sum. Next one, isosceles triangle properties. So we did discuss this a little bit last chapter, but now we're going to go into a little more detail. So this is the stuff that we talked about last chapter. So you have your congruent sides or the legs. The non-congruent side is the base. Your base angles are attached to that base. And then the vertex angle is across from the base or is basically attaches the 2 congruent sides. So these are just what we talked about last chapter. The isosceles triangle theorem. So what this guy says is if I have 2 congruent sides in a triangle, then the opposite angles are congruent. So opposite angle, whenever you have a side, it's the angle that's not attached to that side. So that's the opposite angle. This is the opposite angle. So if 2 sides are congruent in a triangle, then the opposite angles are congruent. Okay, notice that this doesn't anywhere in it actually state isosceles, which is strange. I know it just says if you have 2 congruent sides, then the opposite angles are congruent. Here's the statement that goes with that as well. Okay, you actually need a congruent triangles postulate in order to prove this congruent officially. So we are going to do Euclid's, this is more of an informal proof, but Euclid's elegant proof to prove this, or just show how he did it way back in 300 BC. So here is an isosceles triangle. Triangle has 2 congruent sides. So what Euclid said was, well, if I have a little line of reflection and I take this and I rotate and flip it over to the other side, what I end up with is a triangle that looks exactly the same. So B is still up here. These sides are still congruent. But what happens is that angle C and angle A flip. So his conclusion was, well, since I can flip this triangle over and angle A and angle C are interchangeable, whether I draw it this way or this way, then his conclusion was, well, then it must be true that angle C is congruent to angle A. So that's Euclid's elegant proof. Converse. So as we've talked about in previous sections, the converse is always going to be the hypothesis and the conclusion are interchanged. So here, the converse of the isosceles triangle theorem says, if you're given this time the two congruent angles, so this time I'm given the angles, then you can conclude that the opposite sides are congruent. So all it changes is what you are given to start with. Okay, so let's go through a couple of examples here. Let me give you a big hint. Whenever you have two angles in a triangle, or if you're missing an angle in a triangle, this one as well, always, always, always fill in the missing angle. You can either use triangle sum or you can use isosceles triangle theorem. But this is a huge hint. I mean, I would even like write it down. Like always find missing angles, missing angle measures in a picture. Okay, that'll help your problem solving a ton. So please always, always do that. So in this first example, we are given congruent sides. So if I have 75 here, this would also be 75. Always just write that in there right away. As soon as you see these congruent sides, write in the angles. Okay, and then you can use triangle sum, and that one should be fairly easy. This would have to be 30 degrees. Okay, same here. So don't worry about all of the side length stuff. If you have a missing angle and you can find it, always do that first. So here I have 70 plus 40, which is 110 degrees. And then therefore, this third angle would have to be also 70 for these to add up to 180. So at that point, now you can use the converse isosceles triangle theorem. These are congruent, therefore these are congruent. Okay, so that's how you can set up and solve for x. So now I know that x plus 7 would have to be equal to 2x minus 3. And then solving that, subtract the x, add the 3, x is 10. So then plugging into the picture, here I'm going to get 20 minus 3, which is 17 units of some kind. Here again, 17 units, and then lastly 14. But notice that these are congruent, which is what we needed to happen. Okay, so there's your first two sections for chapter 4.